Hey folks, welcome back to Advent of Code in F#. Day 14, or at least time traveling day 14, because it's actually the 31st here in Belgium. But I'm now getting around to day 14, so let's take a look. I still have some holes to fill in, as you can see, but I think... Oh no, I have some 15 and 16, so I did some of the later puzzles, but 14 is like the gaping hole, and then we can just do a marathon until we hit our 50 stars. But for today, let's take a look at day 14, parabolic reflector dish. Short problem description. All right. You reached the place where all of the mirrors were pointing, a massive parabolic reflector dish attached to the side of another large mountain. The dish is made up of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it in a vague direction. This system must be what provides the energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes and pulleys to a large metal platform below the dish. The platform is covered in large rocks of various shapes. Depending on their position, the weight of the rocks deforms the platform, and the shape of the platform controls which ropes move and ultimately the focus of the dish. That's a very roundabout problem description. Okay, so if we move the rocks, you can focus the dish. There we go. That's what we needed to hear. The platform even has a control panel on the side that lets you tilt it in one of 4 directions. This sounds like the marble game. The rounded rocks will roll when the platform is tilted, while the cube-shaped rocks will stay in place. Yeah, this is exactly the marble labyrinth. Is that a thing? How do people call that? Yeah, this thing, where you have a marble and you can shift your thing in all the directions. Cool. I've never actually solved the programming challenge this week. Interesting. So we can tilt in one of 4 directions, and the balls roll, the walls will stay in place. And we have empty spaces, of course. Start by tilting the lever so all of the rocks will slide north. Yeah, okay, so everything shifts up until it hits something else or a wall. You notice that the support beams along the north side of the platform are damaged. Oh dear. You should calculate the total load on the north support beams to ensure the platform doesn't collapse. What? Okay, so part 1 is a warm-up probably, and then we can do something interesting. So the amount of load caused by a single rock is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Cubes don't contribute to load, so we need to find the rock load for every round rock if we just move everything north. So this is 1, this is 10, and we count the number of rocks in row 10. Yeah, okay, that makes sense. So we tilt the platform once. I can see where part 2 might be going, but okay, let's see. How do we do this? How do we actually do this? North is easy, because then you can just go from top to bottom, left to right. But the other directions, you kind of have to go from the other one, right? If we tilt south, it's more straightforward or even easier to iterate over my grid from bottom to top and east from right to left, stuff like that. That's interesting. So I'm thinking ahead. That's always a bad idea, but thinking ahead, maybe the north roll will be easy, but all the other ones we could make easy if we just do another form of iterating, like generate the locations we need to do stuff with, or generate over the locations we need to do stuff with in a specific order. Okay, what do we need? Do we actually need to know every location, or can we just take a hash map with rocks and walls? Now we need boundaries, because here, if we roll to the north of this thing, we can't roll out of the grid. We need to hit the support beam. That's an argument for a 2D array and not for a hash map containing locations or mapping locations to whatever is at that location, right? Yeah, I think so. So let's grab array 2D again. We did it for day 13. I'm going to do it again for day 14. And I'm going to parse into... Yeah, I'm going to parse into a 2D array and map every character to a union type just for the sake of it. Just to warm up my fingers a bit because it's pretty chilly here in Belgium. Or actually, no. It's winter, but it's 10 degrees Celsius, so it's impressively warm. Which is not a good thing. But okay, let's worry about problems we can solve, namely day 14. I'm going to start parsing the example. There we go. So I want to parse this into a 2D array. That's pretty easy. I think even this will even work. Yeah, there we go. So we have a 2D array, but now I want to map every element. Do I? Yeah, I want to. I want to make it a... so I can exhaustively pattern match just for fun. Doesn't matter what module I use, so I'm going to use the sequence module. And for every row, we have a column or a cell, and we parse the cell. And let's write that parse function, which is a pattern match on the character. This is empty, so we need to define our union. Whatever cell, empty, or wall, or rock. So this is the wall things, and this is the round rock. This is empty. This is the wall. And this is this O or 0. Let's copy that to make sure. Nope, that's not a copy. So this maps to the, rock. And all other cases are a problem. Let's print out what the actual problem is. And that is a character. And if I put nev in there, it's a format string. So yeah, there we go. So we parse our cells and we put it in a 2D matrix. There we go. It's unreadable. Great. That's the only downside to parsing into union types. You lose any sense of a comparison visually from the original problem. So it's a rock, a lot of empties, and a wall and a lot of empties. Yeah, okay, I'm good. So now let's just roll everything north. So I'm gonna write a new type. We won't need it for part 1, but I'm being premature. East, northeast, south, west. And let's not worry too much about all the other ones. So let's roll north, or what's the official word? Tilt, sorry. So let's tilt in a direction. Yeah, let's not worry about direction just yet. So what do we tilt? We tilt what is the thing that the rocks are containing? What's the thing? What's the container called? Platform? Yeah, platform. So I'm gonna call this thing a platform. There we go. Oh, that's not correct. Let's just take platform as an argument and do something in a few seconds. And that's what we'll be figuring out. Oh, what's happening? Okay, there we go. So we have our parser, we have our platform. Let's now tilt our platform north. What would that look like? I think we can just iterate over all the locations, top to bottom, left to right, but very specifically top to bottom, because that is relevant. And then if we, or at least for all the locations that contain a rock, it would be easy to what am I trying to say here? If I have a 2D array and I have some rocks in there and I iterate over every location containing a rock, then I need to figure out where that one rock will end up by looking up until we hit something. And then we need to take out the rock from the original position and put it in the new position. That could work. With a hash map or a lookup instead of a 2D array, it would be easier. Nah, not really easier. But then it would be easier to just update that one key value pair. And now we have to take something out, the original location, and put something in the new location. And I think array2ds, you can't like update them. There's a copy, there's an init, so you can do a lot of heavy stuff. Maybe you can mutually update them, or mutably update them. I actually don't know. Let's see. I don't really want to go that route. My constraint for this year, or for all years, is use mutable data. Never, or at least try to not use mutable data structures. But let's play around with it to see if we could potentially do that. So can I update? Yeah, I can update to the array. So we could do that. Don't really like it, but the alternative is copy pasting the entire matrix and changing 2 elements. That sounds expensive. Do we know how? Yeah, that will be what, quadratic? Yeah, it will not share a lot of data structures between the two. So yeah, that will be a very expensive. Oh, there's a map. Built a new array. What's the complexity for a array2d map? Let's just go to the source code, F# array2d. There's GitHub, yeah, there's a map function somewhere. Let's go to the GitHub. What is it actually doing? Oh, it's using init. Init based. What does that even mean? Based. Where is my init? Creates an array given the dimensions and the generator function. That sounds like a quadratic kind of thing, right? Ooh, let's go to the definition. That should be the first one we see. Yeah, there we go. Yeah, it creates an entirely new array and it does a nested for loop, so it's quadratic. Yeah, and it's even setting it mutably behind the scenes. So we could actually use map. Let's try it with map, and if that doesn't work out, I will rework my algorithm to use hash maps instead of 2D arrays. So yeah, tilting north. What did that look like? We need to go over the location of every round rock. So let's find that. Can I find? No, I can't do anything. So let's write our own find index or find indices of something, of a value. So it's very abstract and we will never use it again because I don't reuse code for Advent of Code. But let's extend the array2d module to have give me the indices containing this value. That's a fun little exercise. So let's maybe even test drive that. I have not test driven a lot of code for this year's Advent of Code. So let's make a 2D matrix containing some numbers. And let's figure out the indices for 2. And that should be row 0, column 1, and row 1, column 0, right? So this is functionality I would love to have. So let's, I did some wishful thinking here. Now let's write the actual function. So let's implement find indices in the array2d module even. So I would like to see it here. And this does not exist, but you can kind of extend existing modules that you did not define. If you say module array 2D, and we can say let find indices for a value and a matrix is whatever, empty array. And now this custom function lives in the array2d module, so you kind of extended it. Or you have an alias which has exactly the same name as the official array2d thing. So for advent of code, that's great. I don't know if I would monkey patch or add functions to existing things. Yeah, I would actually. I use extension methods in C# all the time when writing production code. So yeah, I do it actually. Sidebar. Let's take a look at how we would implement find indices for array2d. So that's just a sequence operation. We return a list. Yeah, we return a list. So let's do a for comprehension. Let's maybe, before we dive into it too deeply, let's take a look at what array2d already provides for us. We have maps, we have creates, we have gets, we have inits, we have iters. What does iter do? Is it like a side effect on every element? Yeah, it's a function that takes an array and a function that takes an element and returns a unit. So that's side effects. Rebasing, don't know, don't care. Zero create, no, okay, so it actually is a very limited thing, except for the slicing we used in day 13, which is awesome. But except for that, array2d does not really do much for us. That's like strike 2. I'm making strikes of when not to use array2d. It'll be way faster than a lookup table, but I love my hash maps. Anyway, so let's do a list comprehension or for comprehension. And let's loop over all the rows. That's length 1. And let's loop over all the columns. That's length 2. So now we have a row column pair. And if the matrix at row call equals the value, then we have a hit. So then we can return the row call tuple. And otherwise we just continue on. Okay, yeah, and I'm looping over a range, and this range is not range, it's just an integer. That's not correct. So I kind of want to loop over a range counting from 0 to the length. And length is not correct. It's -1, right? I am horrible at -1, so that's why I'm defining these helper functions, so I never have to loop over a 2D array again. Because I am notoriously horrible with indices. What's the problem here? More parentheses? Seriously? Or different order? Yeah, I think it's more parentheses or flipping the order. If I don't use a pipe operator here, I don't think I need the extra parentheses. Yeah, I don't. I don't like parentheses, so let's get rid of them. Sorry, Lisp lovers. I actually played around with Racket a lot. It's a great language, so I'm not hating on Lisp languages here. This is okay. Oh, my test contained a bug. That's not how you delimit elements. Okay, let's run our test. I think that should turn green. Yeah, it's green. Let me shut down the benchmark thing. There we go. Yeah, we have a find indices function, which we can use for our platform problem. I'm gonna put everything that's super abstract and generic on top, because it's not really super relevant for our algorithm. Okay, so, or it's super important for our algorithm, but it's like more abstract. And if you define a function, you need to define a function before you can use it in F#, so you can't just like put the most important things on top and have everything implemented below. So it's a bit the other way around in F#, which is a bit weird. If you like read a lot of clean code, it's like put the important things first and then the implementation details or the helper functions below. That's not how things work in F#. Anyway, I'm digressing. So let's find the indices for my rocks. So for my platform, find my indices containing rock. 0, 0, is that a rock? It is. It is. And 1, 0 should be as well. Yeah. Okay, so these are my rock locations, and then yeah, I don't have to sort them. This is the correct sorting for the north tilt. Then I just loop over them, and for every one of those, figure out their new locations, take them out. Oh, will that work? Yeah. If I just use the updated matrix after every tilt of a single rock, it'll work for subsequent rocks, because the subsequent rocks have not moved yet, but the subsequent rocks have not moved, but all the ones we did see have to have moved before we take a look at the next one. Otherwise, we will not have the correct result. So now one by one, tilt rocks north. That's what we have to do. So is that like a fold? That sounds very much like a fold. So let's fold over our rock locations. Tilt rock. Tilt rock north. Let's just keep the north in there. And we need a state, which is the original platform, right? So we're not going to wrap some custom state. We're just going to use platform as our state for our folding function. So now we need to define tilt rock north. And it needs to return a version of the state. So that's the platform for us. So there we go. Now we have a helper function, tilt rock north. And now we made the problem one step smaller, which is always a good thing. And because we return the updated platform here, subsequent rock locations will see the updated version. So this fold, is it fold left, fold right? I don't know. I think it's a fold left. I have no idea. In F# we don't really do fold left or fold right, I think. It's a Haskell thing, right? Oh, the image would actually make more sense. What's my two folds? There we go. We're doing a fold left, yeah. So we take the first element and the second element, new state, new state, new state, yeah. And fold right just goes the other way around, which we will never need, or at least not today. So yeah, we're folding, and the folding takes care of the updating the platform in the order we want. So now all we need to do is be able to tilt a single rock north given the platform. In order to do that, we need to figure out what is everything above me, and we need to figure out the first thing that will stop us, which is the supporting beam or the boundaries, another rock, or a wall. Yes, I was convincing myself internally for a second here. So, ooh, I think that array2d slices are actually a pretty cool feature to use here. So let's take everything above rock. We need the location of rock, right? Oh yeah, these are the indices, sorry. So this is an index actually, or a location. A row and a column tuple. Yeah, that's what we need. So let's grab everything to the north of this location. So that is a platform. Grab everything. I'm not gonna write a abstract data type kind of helper function. I'm just gonna dive right into the array2d module here. And I'm gonna slice, sorry, I'm not even gonna dive into any kind of module. I'm gonna slice. So I'm gonna take from platform the same column, but everything above row, which means it has to be smaller than row. So it has to go from 0 to, and then my mind is blanking. And we need to give this some type help. I think we do. So let's write an alias for the platform type. Parse returns a platform. So where's my parse? Oh, this is the parse. This is the parser, and that has type platform. which is basically array2d. Array2d in type form is this, but you need to give it a type. For us, it's a platform containing cells. But we could also make it generic, but this will work. So let's define cell, define platform, and now we know the type of platform, and we can use the type platform here. So we know it's an array2d, and actually introducing platform and seeing, no, this will work actually. Cool, cool, cool. Use incomplete expression or invalid use of indexer syntax. Sorry. Platform should be a platform, but it's not. Why is platform not a platform? Oh, so all of a sudden it's a platform. So I just put my type hint in the wrong place for my compiler to really be helpful. So there we go. Yes, no, yes. Okay, cool. So this is everything above the platform, the rock. But it'll give me everything from the topmost thing to the nearest thing. So I kind of want to reverse that. Ooh, that's cool. I was thinking, oh shit, this is a 2D array. If you slice stuff, sorry for the bad word. If you slice stuff, you get a submatrix. But because there's only one thing here instead of a range, let's see if that's why this is happening. Above is now a 2D array cell, yeah, but if I just put one integer in there instead of a range, I get a array back, not a 2D thing. But that's actually pretty cool. That's one win for array2d again. But so now we can just easily reverse that. And then we have everything closest to the rock and furthest away. So now we can figure out what stops the rock. And what stops the rock is either nothing, so we hit the top, or something being another rock or wall. And we also need the index of where this is happening, right? So let's do indexed. And let's map. Actually, let's do a map I, which takes an index and the element, and we can return index plus 1 and the element, because why actually? Yeah, because that's the offset with the current element. If we are at row call, and this has to go from 0 to row -1 probably. So this is a bug. I should just write some tests or see this code work instead of thinking I know everything. So let's do that. We have a rock. Let's define, let's take this one. Third row, first column. So third row is 2, sorry. First column is 0. There we go. So let's take a look. If we take everything above me, I should see rock. Yeah, okay, cool. And if I then index that, let's maybe first reverse and then index, that makes more sense. So if we first reverse, it won't do much with rock, but then we have everything closest to me first. And if I then do map I, yeah, so I am at row lock, and 1 above me is a rock, 2 above me is another rock, and then we have nothing. So this is what we need. And now we need to find the first thing that will stop us. So that's an above. Try find the first thing that will stop me. Let's call it a blocker. And if it's nothing, we know we're out of bounds. We hit the supporting beam, and if it's something, we know we found a blocker. So we find, for example, a wall. Takes an element, sorry. takes an element and returns a bool. And if what? Returns the first element for which the function is true, returns none if no such element exists. Okay, so we don't need to return an option, sorry, we need to return a bool. And the option thing is inside the try find thing. Yeah. So if we don't find anything for that is blocker, we have the supporting beam, and that has to be row 0, right? My next location should be row 0. So let's first focus on, I'm doing too much in my head. Let's take a step back and let's do is blocker first. So when is a cell a blocker? That's a straightforward pattern match. Walls block me. Other rocks block me. Empty does not block me. Oh yeah, and that has the, this has the index as well, so we kind of need to do something with that index. So I'm just gonna extract or destructure on the tuple in this element, in this array, and just use cell to filter or to try find, but kind of keep the I in there. What is the return type of this thing? Is it a tuple? Yeah, it's a tuple inside an option. Cool. And we should return the updated platform at the end, right? We're not updating the platform just yet, but we should update it. And now my compiler is happy again. Okay, so this is tilting rock north. This is checking whether something blocks me. I don't use the index, so I can just wildcard it. So this is the thing that's blocking me. We can just pattern match on it, or we can do fancy option bind things. Let's pattern match up on it. So let's match on blocker. If we did not find a blocker, we kind of hit a beam. If we did find a blocker, we don't care what blocks me, we also update. So I think this is the algorithm or the skeleton for the algorithm. Now, if we don't find anything, that means we hit the supporting beam or the bounce. Then we just move this single rock from its current location to 0, row 0. And we need to remove it from its original location. This will be so much copy pasting. This will copy paste a lot of array2d things, but okay, let's do it. So it's a array2d map. Ooh, there's a map I. That's actually very useful. So it's row, p row, p column, and value, and it returns a new value, or it returns the mapped value, right? Yeah. So what do I want to do here? If I am at the old location, remove myself from this equation. If I am at the supporting location or the bound where I should end up, I just insert myself there. That's the plan. So if PR equals row and PC equals column, then I should remove myself from the equation, so that location should become empty. And else I should just keep whatever was in there. So that's correct for replacing myself or removing myself. Then I need to insert myself in the new location. So if PR equals 0 and the column is the column I am currently at, then I insert myself there, so that is a rock, and otherwise we keep the current value in there. So this is a very expensive operation, I think. Copy pasting an entire 2D matrix just to shift or to update two values, all in the name of not using mutability. If we just used the setter, we did not have to do this. But just because I can is Just because you can doesn't mean you should, but I would in this case. Only if the CPU starts to burn for part 2 or something, I might do a different approach. But anyway, if we hit a blocker at index, so that's the offset, that's how much my row index has to offset. Yeah, so that's the same thing. It's the same thing. So if I'm at the location I stop, if I am at the offset, no, if I'm at row minus the offset, then I insert myself there, and otherwise I keep whatever was there. So yeah, don't like that auto formatting. Why are these two branches so different? Oh, because there's a big subtraction in there instead of 0. Okay, so this is in theory, all I have to do to tilt north. Let's take it a step. So we have above, we have our blocker. We find a blocker, which should be, what was above me? 2 rocks. So yeah, 1 rock is what should immediately be blocking me. So the algorithm is finding that. Great. And then we update ourselves. So we should see, actually, if this is blocking me, and I am at row 2, I should stay at row 2, right? This is not correct. This is not correct. I was doing a +1 here. Was that a good idea? Probably not. Let's get rid of that. If I get rid of that, I don't need to do the mappy. I can do the indexed. It's the same thing. Let's go over that again. So I am currently, my platform looks like this, and I am investigating row 2, column 0. So this one. So that should stay in place actually. It should stay at 2, 0. Rock 0 is blocking me. So then I need to 0. I am at 2. Yeah, that's better. I think that's better. Okay. So yeah, let's give that a shot. It's a very big step, writing all this code and just like running through it once. Yeah, let's check it out. Platform. Tilt the platform north. I see a lot of rocks on top and a lot of rocks just beneath walls. I think we might actually be getting close to somewhere. Yeah, let's take a look. So I want to see 4 rocks, 3 rocks, 1, 1. 1, 2, 3. Oh, we're missing a rock. we destroyed a rock. It's like 4, 3, 1, 1. And I see 3, 3, 1, 1. We got rid of some rocks somehow. That's not good. That smells like the fold problem I was discussing. Let's take a look. Where's an interesting case? Okay, so on row 3, no, that's not interesting. That's not interesting. Where's an interesting one? Actually, almost everything has rolled to the top. Oh, sorry, that's not the initial state. So yeah, this one is an interesting one. This one, this one is actually also an interesting one. That's actually the bug I was most afraid of that I would do, and I ended up doing it. Okay, this is interesting. Let's verify these 2 walls or rocks. I only see 1 again. Yeah, there's bugs. It seems like if a rock should stop me, or if a rock that has moved before, this one, if this one moves up here, it should stop this one, and that one should end up here. Maybe that's not really working. Let's do a degenerate case. Let's write a 1 column, whatever 5-row 2D matrix and have that tilt north to verify. So I'm gonna do that immediately in a test. No, I'm not. So array 2D, one single. Let's start with a rock and then an empty and a rock. What do we expect if we tilt this north? We expect everything to shift up to the top two rocks on top, right? Yeah, we have our bug already, cool. What if this becomes a rock? We get rid of rocks, that's even crazier. So the problem will probably be with our offsets. So this is an example of failing. Yeah, this is failing, so I'm gonna encode it as a test so we don't forget about it. So that's my input, that's my actual, and my expected is just the one rock shifting up one. So this becomes rock, this becomes empty. This is what I should expect. But it's not somehow. Why is this not okay? It should be an array 2D. Yeah, that's true. There we go. So let's run that test. The test is failing. Let's debug, but I mostly just debug by having using my REPL. Sorry, I don't use a ReSharper, sorry, a Rider or Visual Studio debugger. I just stepped through my code in the REPL. So it is platform. So I'm just aliasing whatever the REPL just returned to me as the it variable. That's always the latest, the result of the latest evaluation you send to the REPL. So now you can type let platform equals it, and now you have a variable called platform containing that thing, which is what's in here. So now we can start, start going over it. So let's find indices of rock. Is that correct? Sorry, that's my already shifted rock. My already shifted, yeah, this is the one I kind of want. So this is what I want to use as my input. What the hell? What the hell is happening here? Oh, that's M, not it. Okay. So if I just select this and then run it, so it's not a let binding, then it should use it. If my formatter would not screw me over. So never mind, what I'm saying is correct, but I'm not getting it to work. But I'm just gonna say platform equals M, which is the thing the let binding binds to. So now I do have the empty in the middle and not on below. So yeah, sorry for that detour. We are still tilting north. I'm gonna grab this nested function, send it to the REPL, and then I can test that outer function body a bit. Yeah, that's better, 0020. And if I fold over it, we lose a rock. So we have our bug, which is good, I guess. So we have row column. Oh yeah, now we're folding. We're folding over this array. Let's do the first one. Let's make sure that does not destroy anything. So it's 0, 0. And if that works, then we're gonna have to start the debugger. Some people asked in the comments, like, how do you debug F# scripts? Let's do that in a second to show a bit. But first, let's... No, you know what? Let's actually do that. I'm gonna put a breakpoint there. Again, if it lets me at least. Why can I not put a big breakpoint in there? That's interesting. I used to be able to put breakpoints in F# scripts. What's happening? Toggle breakpoint of 9. A breakpoint could not be inserted at this location. I am sorry. So I can put it on, I can put it on stuff in here, but in this inner function. Oh, there we go. I don't know why that didn't work on the LED binding. But okay, so we can put breakpoints in there. I think you can say start debugging if I right click my Visual Studio F# interactive window. I'm not sure if that works for Visual Studio Code. But I'm using Visual Studio, so then it's possible. The current F# interactive session is not configured for debugging. Enable debugging in F# interactive settings. Attempt debugging, no. Let's do that. Interactive settings. Where do I do F# interactive settings? Where are my interactive settings? I actually have no idea. Where can I find F# interactive settings? I was thinking if I press my Ctrl Q shortcut, which is the search anything, you should be able to find like everything. Oh, there it is. F# tools, F# interactive. Yeah, okay. So enable debugging, definitely. And that's the power feature that enables you to debug scripts. I hope, at least. It's been a while since I tried it. And Visual Studio F# integration does not always like a strike gold, so hopefully they did not break this. Let's reset. Yep, let's start debugging, or let's send everything to the REPL first. Yep, there we go. Let's start debugging. Exciting times. First time Advent of Code 2023 that I'm debugging F# code. There we go. So we're in debugging mode. You see my profiler here, or my diagnostic tools. Let's run some code and have it break or hit our breakpoint. So I put a breakpoint in here. Wow. Wow, wow, wow. Breakpoint will not currently be hit. No symbols have been loaded. I know, it's an FSX file. I don't have symbols. Interesting. Let's see if it actually will break or won't break. So this is the line of code that would have triggered the breakpoint, but it's not. So yeah, of course this is not working. I have used this in the past. I am 100% sure that you can do it. Maybe I had some super uber resharper tooling help. Do I have resharper installed? I don't think I do on this computer. I do. I even have resharper installed. That's insane. Why is this not working? Do I have like an active license? It's like even the fancy ass expensive license. So yeah, this is beyond disappointing. I think if I just use the Rider, the IntelliJ or the JetBrains product, that would have just worked, maybe, or at least no, maybe not. For F#, they're always lagging behind a bit as well. But debugging a script, that should be super doable, right? We could debug it if we just put this in a project and build it like we would do with C# code, but that's so much of a hassle. I don't want to go through that. So let's find another way to debug. So yeah, I'm putting this on this one. I'm putting this one on Visual Studio. It's not my fault. This worked. I'm 100% sure of it. If you debug F# scripts, not F# projects, but F# scripts, and you know what I'm doing wrong, please shout out in the comments below, because I have no idea what I'm doing wrong or what I did else in the past. Anyway, we have a bug. We have disappearing rocks, and it's very likely 100% sure in this tilt north function. And it's probably, I think about it, has something to do with this madness. or this offset calculation, or the actual offset itself. Where is my offset? It's the I, so it's the index, so it's this thing. Yeah, let's take this step by step. So I'm kind of doing, what if I had a debugger? But I don't. Row and column are 2, 0, I guess. Sorry, that's not my platform. Is M still in there? No. Let's grab M. So that's my platform. There we go. And let's step through this fold function, or the tilt rock north function that we use as our folding function. Right above me is empty, so that's 0. Sounds tricky. Yeah, actually, let's do the map I thing again. And let's do +1. Because I don't like to see 0. That's like, don't do anything, don't offset yourself. Which is actually correct. This does not need to stop us. This needs to stop us, and that's offset yourself by 1. Map I, is that actually correct? Yeah, it contains empties, so it is correct. And if this is a rock, you don't actually have to do anything, so you have to stay. Actually, I'm sorry for this back and forth, but it is correct. It is correct. I just convinced myself the other way around, and now I'm convincing myself around again. So yeah, this is the offset I have to change my current row with, if this were a blocker. And this is a blocker, so I have to offset myself by 1, so I end up in here, which is 1 above me. Yes. The only thing I don't like is that this is saying indexed, but that index is like super important. You have to know what the meaning of that index is. And now it's not literally in the code, except maybe down here. And there's a bug, so probably the bug has to do with the offset, but okay. Or is blocker, does that one look correct? Walls block me, yes. Rock blocks me, yes. Empty blocks me, nope. That looks correct. So what is blocking me? The rock on 1, I hope. Yes, we find it, cool. So we are in our sum offset. So offset is 1. Sorry, offset is 1. Why am I typing rock? It's because it's getting late. Yeah, it's because it's getting late. Holy moly, it's late. I thought I would hammer out this puzzle in 10 minutes. I've been at it for an hour, so yeah, but that's life. So now we're doing this map thing. Why am I doing a map I? Oh yeah, because I need indices. Yeah, makes sense, makes sense. And this is where the bug is. I'm sorry, did the bug just not appear? The bug did not appear. This is the correct solution. So the problem is maybe not with this, but with this, the first rock. So that would mean the problem is with 0, 0, not 2, 0. So let's make row 0. There we go. Let's try it again. So I should have nothing above me. That's correct. I should have no blocker, so none. That is correct. If I have none, I take my original platform. And what should happen if I don't have a blocker? I should move myself up to the support. Oh. I am at my current location and I should not be moving. So that's what's happening. So this actually has to go first. If I'm at the top row, no matter... Okay. That's a stupid bug. If I'm at the top row, then I'm always a rock, even if I were there, sorry. And only then will I start looking at removing myself. So this should be what we expect. Yeah. Okay, then is the same bug in here? Can this also be? Probably, I'm not sure, but let's keep our code symmetrical. and then start thinking about it. Can this be this? So that means that row minus offset is row. That means that offset is 0. Offset sometimes is 0. If something directly above me is blocking me. So yeah, the same bug would be in there. Okay, now I think we're okay. So let's try our test again. Yeah, this test now succeeds. I see testing done, so there's no failures in there. So let's tilt north again. Do I see 4 rocks, 3 rocks, 1, 1? Yeah, and 2 here. Yeah, okay, this looks correct. So even without a debugger, we got there. Hopefully. So what was the thing we needed to do to count, find rock, load, which is the index starting with 1, reversing. Okay, so we need to figure out the index of a rock starting from the last row. Okay, let's maybe before I do that, try to parse the input to make sure it works for that as well, because we are copy pasting a lot of arrays and that's a bit heavy. Ooh, that was already very intensive. Let's see if it was just printing intensive or also calculation intensive. Okay, apparently it's just printing it out to the console. That's slow. Yeah, it's only 100 milliseconds, so that's good enough for part 1. Part 2, we'll see. Okay, so I think we have our tilted platform, but now we need to I'm already thinking ahead, what would it mean if I was tilting in other directions? Oh, this would hurt. I would have room for so many of my one bugs in here. Okay, stop thinking about the future, start solving the where we are. So we tilted, and now we need to figure out the rock loads. And for that, we need to index every row. And for every rock in there, or we need to count the number of rocks in every row, multiply that by its index starting from the bottom. So what's the first problem I want to solve? Finding the number of rocks on every row. Sounds like a good first problem, right? Yeah, so let's find the number of rocks on every row. Let's do that. So I have my 2D matrix, and then I want to loop over every row. I want to loop over every row, so that's tilted. Array 2D, length 1 is the number of rows, minus 1. And we've been here before. Let's not do the pipe, but let's do it like this. So we don't need parentheses. That's all the rows. Let's grab the entire row. So that's row, grab me, row, tilted, grab me, row, row, and everything in there. So now we have done nothing. But for this, everything in there, that's a array containing everything in the array. So let's just filter out everything that is rock, right? Round rock, yeah. Now we have all, why is this not working? Because we need array. There we go. So we have all our rocks in there. Now we just can sum them. Sorry, so we filter them and then we sum or count the number in that thing. So that's 5243, 5243, and then 0031, 00. Yeah, that's correct. And then we just need the indices as well. One, two, three, four, five, 6, 7, 8, 9, 10. So we can just count. We can just reverse it and map it. Yeah, we can just reverse it and map it. So there we have our counts. Let's reverse our counts. And zip them with an index, or let's index them. And let's increment by 1 so we get rid of the 0 index. So it's 1 based. And 10 should have 5, yes. 9 should have 2, 8 should have 4. Yeah, that looks correct. Now we can do the actual summation. That's a map containing the index and the count. And we should multiply the index by the count, and we should sum that. That should be our result for part 1, 136, 136. Let's run it on input instead of example. There we go, there we go. And there we go. Finally, we get an answer. And that is correct, great. I am dreading part 2, but let's first commit part 1. What day is it? 14. Crazy, crazy. That's over the halfway point. There we go. I'm not even going to copy paste my script for part 2. Let's take a look at what they're expecting us to do. You need to move the rocks to the edges of the platform. A button on the side of the control panel labeled spin cycle attempts to do just that. Each cycle tilts the platform 4 times, there we go, oh boy, so that the rounded rocks roll north, then west, then south and east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. So we have, why only 3 cycles though? Why do they only give 3 cycles? So that's 1. Oh, cycles. Cycles is 4 directions, sorry. So yeah, this is a good example containing a lot of... So the process should work. Is it true? If you always do the clockwise tilting, can you solve any marble labyrinth? I have a hard time convincing myself, but probably. Oh dear lord. So this process should work if you leave it running long enough, but you've still worried about the north support beams. To make sure they'll survive for a while, you need to calculate the total load on the north support beam after... Oh dear lord, that's a lot of cycles. I'm hoping for a cycle within the cycles. If we have to run our code for this many iterations, that can be what we have to do, right? But then we are copying a lot of 2D arrays. Yeah, I'm not even going to think about part 2. I'm going to have some relaxation time with the family before I start looking at part 2. Yes, so let's take a look at how we solved part 1 and wrap up for today. Part 1 was figuring out figuring out the load on the north support beam after we tilted the platform north just once instead of 1 billion cycles. We did that by extending the array2d modules, so we find indices for a given value. So we find all indices that contain that value. We use that to figure out all the locations containing rocks. Then we did some minimal parsing. We defined the type we did not use for part 1. Why do I keep doing that? Let's get rid of that. Yeah, our parser is pretty basic. And then we spent a whole lot of time on some stupid bugs and a whole lot of time on copy pasting array2ds. Also something interesting, we used fold yet again. Fold is super powerful, but also very tricky to debug, as you saw, because you thread an updated state through each iteration. Or it's not super tricky, like It's a pure function. It has inputs and outputs, so you could just step through it. So it's semi-tricky. But what happens if we tilt the rock north? That works because when we find out all the rock locations, they're already in the top to bottom sorting. If we work for part 2, this will have to change, and maybe that's not the only thing that has to change. Also, there's a find everything to above that has to change. And those are probably the only 2 things that have to change for part 2. I'm already skipping ahead, sorry. So yeah, we find indices for rocks, and then we fold over every of the rocks and update the platform accordingly, given this tilt rock north function. Tilt rock north takes the platform and the position of a rock, and then figures out where this rock will end up. It does that by looking at everything that is above that rock. And here we do array to D slicing, and I found out that it returns an array instead of a 2D array if you just provide an integer instead of a range, which is awesome. So we find the first blocking cell. If we don't have any, we hit the beam, so we end up at 0. Otherwise, we end up just below the blocking entity. And we use a trick where we stubbornly refuse to update an array to D inline, or mutably update an array to D, but instead I use map I, which takes a mapping function and an original array to D, so the platform, and it just applies this mapping function to every element. And here I say, if something needs to change it, otherwise maintain the default or maintain the current value. That's something I learned from React or Elmlang. I think from Elmlang. Elmlang developers use a lot of this crazy ass mapping to copy paste records or data structures. And actually it's pretty elegant once you know it, but it does not sound like a very performant way to solve problems. Or at least not CPU and memory performant. But it works. And it was good enough for part 1. Part 2, we'll see. Yeah, and then we just did some summing of the rock loads, which was not the hardest of problems. And again, I wrote very minimal tests. And we only wrote the one test to tease out a bug where I got rid of some rocks. Rocks disappeared, that was not cool. So part 1, really like the puzzle. I have some ideas about part 2, but my brain is too tired to dive into it right now. So I just won't. I'll pick this up again tomorrow when I have more energy. I hope you learned something fun, something new. I hope you enjoyed yourself. If you can debug in Visual Studio, as I said, please let me know, because I am at a loss. I don't know what's the problem here. And otherwise, I hope to see you again for another Advent of Code in F#. Bye-bye.